Welcome to a lesson with Dr. Powell. Let's take a look at outside multiplication of a group. So start with a group, z mod 6z cross z mod 4z. So these are ordered pairs. The first thing is something that lives here, and the second thing is something that lives here. And the group operations in each component come from this group and that group, respectively. Okay, so what does outside multiplication mean? Well, we're going to take another group, and suppose we take z as our group. Now we can take an element, say like 3 in z, and we're going to define somehow how we can multiply 3 to something like maybe 2 bar and maybe like 3 bar, where 3 bar lives in here and 2 bar lives in there. What should this be? And we want it to behave in a very nice way, meaning that this multiplication should distribute over sums and everything naturally that you would imagine multiplication to do. It also needs to be well defined, this multiplication. Fortunately, since this group and this group actually come from z, and everything about them, namely what's under the bars, is something in z, z is a very natural thing to choose as an outside multiplication, and it works perfectly fine. So in particular, the way this would work is you simply just plop the 3 under the bar in each one. So you kind of imagine that 3 is actually just behaving in the respective mod that we want component wise. Okay, well, that works fine for z, but what if we change things up a little bit? Let's still work with z mod 6z cross z mod 4z, but let's look at a different kind of a group. What if, for instance, we chose z mod 12z? Take something in here. Now we have a few different options for modular arithmetic, something in here, here, and here. So let's kind of think of a notation. Maybe an element in here we can represent with a bar, in here maybe with 2 bars, and in here, I guess we could do 3 bars. Okay, so something that's going to live in here will represent with 3 bars. Okay, so let's look at what's going to happen here. Now, in order for this multiplication to be well defined here, that means that this thing, whatever it is, has to be able to go inside of this group and inside of this group freely in a nice manner. Meaning, in particular, that there's a nice function from here to here and from here to here that preserves addition. Now, from a previous video, this is simply checking to see if this guy right here is going to be contained in, or can be mapped to, well, since it's just being put into, basically we're just seeing if this is going to be inside of the identity for this guy, and it also needs to be inside the identity for the other guy over here, which I call the identity to identity criterion, meaning this 0 in here needs to really be 0 here and here. And if that's true, this will work as a marvelous outside multiplication. And we'll look at an example of that. So let's see. If we multiply by anything in 12z, notice that for sure 12z is contained in 6z, because 12 is a multiple of 6. So anything that's multiple of 12 is a multiple of 6 as well. So it's in there. Also, 12 is a multiple of 4. So anything that's multiple of 12 is a multiple of 4. So it's contained in there. So hence, this is a nice outside multiplication, and that's how we check. We just simply check to see if 0 here is 0 in both parts. Okay, so this is a nice outside multiplication. How would it work? Well, let's think. There's my outside multiplier. Let's multiply it to a group element here, say 2 bar and 3 double bar. And what's going to happen? This just kind of pops this freely, can transfer into both of these groups. So it can just magically turn into 3 bar times 2 bar and 3 double bar times 3 double bar. So it can jump in as desired from being on the outside freely from this idea of being well defined and how it travels into each one of these respective groups. So then you could complete this computation. 3 times 2 is 6. So that's 0 bar. And over here, 3 is like -1 mod 4. So this is really just 1 with the double bar. So this has an action. It acts on this, and it produces that. Thanks for watching.